Hello and good afternoon, everyone, and welcome to this exciting RMETS event looking into the Met Office's Forecasting Centre and finding out a bit more about what they do over the next hour or so. Hopefully you can see my slides okay. Just a few bits to run through. First of all, is on Zoom, you'll be able to ask questions as we go along. We'll leave some time towards the end to go through the questions. So at the very bottom, you'll be able to see there's a Q&A tab. You can put your questions in there. I think you can like the questions as well if someone else has already asked the same question, so we don't sort of duplicate too much. There is a chat function too, but try and just stay to the Q&A as that will be the one monitored the most. Also, if you want to make your PowerPoint slides bigger, you can close the chat and enlarge the screen. And if you're having any technical issues, it could be browser related. I think the best one to use is Chrome overall, but it might be worth just changing browsers as well. Just a little thing to say, if you'd like to sign up to the Met Matters newsletter, you can do. Exciting monthly newsletter full of weather and climate stories. I think the next one coming out is to do with trying to dry your washing during the rainfall. So during the rain we've been having, how to still keep your washing outside if it's possible or not. This is an RMETS event, so if you would like to become an RMETS member, you can find out more information on the website. I just thought I would introduce myself quickly. My name is Greg Dewhurst. I am one of the events coordinators within the RMETS, but I'm also a senior meteorologist who works alongside Stephen and Amy. So Amy and Stephen are going to be talking to us over the next hour or so about the Operations Centre in Exeter specifically and what goes on there. Amy joined the office, the Met Office, in 2015, initially in defence, but has been working in HQ since 2020 as well, and still goes abroad at times, most recently to Antarctica, and will be going again in February, which is exciting. Stephen Keats started a similar time to me, and has worked through different areas of the Operations Centre in Exeter, as well as some defence work, and is currently part of the Expert Weather Hub as well. So Stephen will be talking about that as well. So I think that is enough from me. So I'll stop sharing my screen and hand over to Amy.
Great, thanks, Greg. Let me just share my screen. This one. The presentation slides. Like so. So, let me just sort this out. Hopefully you can all see that okay. So, this talk is going to be about the Met Office Services Forecasting Hub. So I'm just going to start off with where exactly that is. So we've got the map here, and we're down in Exeter in the southwest, which is a lovely place to be. Been here since 2003. I've got some pictures here of the outside of the building. So we've got a very beautiful building. This picture in the top right is the...
Sorry to interrupt, Amy, quickly. I think it's not showing the slide screens. It's showing the actual main slide.
Right. Oh dear. Hang on, let me try again. Is that better? HQ1?
It's your word notes on that one.
Okay, hang on 2 seconds. I don't understand. Is that the right one there?
Yep, perfect.
Sorry about that, everyone. So, right, this should have the pictures that you can all see. So we've got the Met Office building. So again, it's a very beautiful building, and it shows on the inside as well. So this is what we call the street. It has a little stream running through it, a little nod to the surrounding wildlife. And it's sort of a great interactive place to be, lots of spaces to have small meetings with colleagues, and lots of spaces to catch up as well. I've also included on here just a little bee orchid. So obviously as an institution that is very much climate and environment focused, we do have trying to encourage wildlife around. So this is one of our biodiversity things, and we do see some bee orchids around the local area. So what does it look like inside the operations centre? So we've got this picture here. So you can see it's a very open plan space. It's on one floor space, and we have got large screens. We've got this big screen at the front, and this is where the chief forecasters display satellite images and anything that's important for the weather that day. Most stations have several screens, so you can look at multiple parameters at once, and we're clustered together in groups in teams of which are working. So who is in the Services Operations Centre? So we do have a mixture. We've got forecasters, we have IT services, we have some managers, and we also have some civil contingency advisors as well. And we'll go through who exactly they are later on too. The Operations Centre is organised into benches, and we do have, since COVID, a hybrid office and home working operation. But we often do have lots of people in the office, particularly on busy weather days. It is a 24/7 shift role, so we do see shifts, and they generally go from 7:30 in the morning to 7:30 at night, and we have night shifts that go 7:30 back towards the morning as well. Move on to the next slide. So, and how is it structured? So we have at the top, so we have different layers of experience within the Met Office. So the very top is the Principal Operational Meteorologist, and they are in charge of the sort of overarching weather story and sort of main themes of the day. Then we go, next is the Expert Operational Meteorologist. So that's the level that Stephen is at, and it just sits below the principal and in charge of long range and global, and Stephen will talk about that a little bit later. Next, we have Senior Operational Meteorologist, which is where I sit, and these are both team leaders and working in specialist areas in the Met Office in these different benches. Below that, we have our Qualified Operational Meteorologists, so they're qualified forecasters, and below that, we have our Foundation Operational Meteorologists for those who are in training. So we do have quite a long training process. It's 6 months in the college, and then usually 6 months on the job training as well. So it's quite a long process. We do have a range of experience across the bench and through the Operations Centre. So for many of you here today, what do we actually do? You may be aware of our website, of national severe weather warnings, and also things like the shipping forecast. But you may ask, what is the rest of the forecasters doing in such a large floor plate? Isn't the weather the same for everyone? Well, not quite so. We do have different benches, and it depends on what the customer is looking for and what kind of forecast they'll receive. So we have different benches, one of them being aviation, with the Flood Forecasting Centre. We have a space weather bench. We have a media services bench, surface infrastructure, hazards, and defence. And within those, we produce different forecasts. And on that basis, I will hand over to Stephen to talk about the Expert Weather Hub and Marine.
Thank you, Amy. Hopefully you can see my face now, which may or may not be a good thing. Let's attempt at sharing a screen, see if this goes well. One of the problems of hybrid working is the ability to share PowerPoint screens on Teams and the other things we look at. So hopefully, is this working? Anyone see anything? Can someone just let me know if they can see that?
Yeah, that's good.
You can see that, okay, brilliant, good. Okay, yeah, so I'm going to talk about the Expert Weather Hub, which is where I primarily work now, and also our marine forecasting side of things, which is where I worked up until a few years ago. And it's just going to work. Just make sure this is going to play. There we go. So yeah, for our Expert Weather Hub, if you've been in any of these chats before, you may have heard this has previously been referred to as what we call the guidance unit. But our work has evolved over the last few years, and we in our team tend to do more than just produce the forecasts. We're doing an increasing amount of research and innovation, trialing new models, diagnostic tools and whatnot. So there's more to our role than purely weather forecasting now. And this probably applies to other roles as well within the Met Office. But on that basis, we changed our name a little bit to become the Expert Weather Hub as of last November. Primarily, though, this is made up of chief operational meteorologists and deputy chief meteorologists, such as myself. And in our team, we, as well as obviously looking at the day-to-day weather forecasting side of things, we need this strategic awareness from the Met Office. It sounds a bit corporate-y, but essentially, things that could be really impact UK PLC, our own reputational brand. So these are the big ticket weather items primarily. And within all that, then we set ourselves the overall narrative is our chief role. So this is looking at all the different models, looking at the main themes, identifying anything that may potentially lead to a warning or something hazardous for the UK and indeed overseas as well. And we operate everything from the nowcasting timescales, which is kind of 0 to 2 hours in the future, all the way out to seasonal and sometimes beyond as well. So that's several months out in the future. So all timescales, and increasingly so, we're not just looking at the UK weather, but we're looking at the weather around the world as well. So lots of global interests, and the Met Office is seen as a global partner of choice for weather forecasts and climate forecasts around the world these days. Day-to-day life then is our suite. So that's our model, our family of models that we run in-house at the Met Office. Is that telling the right story that we wanted to do for wherever we're looking? And if it is, brilliant. That's just made my day a lot easier. If it's not, though, as is often the case, there are differences in the models as you look further into the future. Then what is the best story, and how do we tell that? How do we modify models to tell the right story? So that takes up a lot of my time on a day-to-day basis. And off the back of all that, you need to then consider: do we need to consider any warnings? In the UK, this is the NSWS service, which I'll explain a little bit about in a few moments' time. And off the back of that, also issue the guidance, which is this overarching narrative that other operational meteorologists within both the Service Operations Centre here, where I am now, and around the country and other places in the world, would then take off the basis of that and then cherry pick the finer detail that they can pass on to their customers with more specific interests. Part of my day-to-day role as well is constantly liaising with our other partners. So our civil contingency advisors, CCAs, who are established around the UK, and have a great sense of some of the impacts that certain weather events may occur on one part of the UK as opposed to another, and have more local insight than I may necessarily have. And the Flood Forecasting Centre, FFC, works closely with Natural Resources Wales and the Environment Agency, and is obviously particularly pertinent when it comes to rainfall and flooding impacts. And when it comes to things like extreme heat or extreme cold, close liaison with the UK Health Security Agency, UKHSA. That's kind of the operational side of it in a very quick nutshell. But as I say, about 20% of my time is also given to developing forecasting capability with other science teams. So for some of the work I'm particularly involved in is evaluating different models, different visualizations, different diagnostics, because it's a rapidly evolving science, and trialing them to see whether they are actually providing the best sort of steer and the right track in which we want to head, i.e. getting more accurate weather forecasts out to everybody who's interested. And also within our role, we look to lead on and develop CPD, continuous professional development, obviously something important with the Royal Met Society as well. And at the pinnacle of the forecasting operational side of things, we are seen as sort of role models, and our aim is also to inspire other meteorologists, perhaps newer to the Met Office as well, to be the best they can be within this fascinating place to work. So first of all, then, looking at the Expert Weather Hub, it has two sides, UK and global, as I said. For the UK side, probably the most important thing we do is a consideration of whether we need to issue any warnings for severe weather in the UK. I'll come to that in just a second, but on a day-to-day basis, we produce what we call guidance documents. So an example here is shown. I'm just going to strut my screen around so I can just look at it so it's not quite so at an angle. So if you can see where I'm hovering the mouse here. So here's an example of some of the graphics we show in the short range guidance. This is our high resolution model data with cloud and precipitation on, and our chief operational meteorologist has written some comments on one particular aspect of it, in this case the risk of some showers through the rest of the day and into the overnight period. And you'll notice there's some specific details in here, but it's not necessarily saying where and when these showers exactly occur. That's down to the meteorologists who are perhaps talking direct to customers in one particular place. We produce charts, both analysis charts, as you can see here, from yesterday morning, as well as forecast charts out into the future, which are called the FUSXs and ASXs, if you're familiar with those terms. And someone asked me the other day, actually, are these charts automated? And no, they're not. They are all drawn from scratch at the moment. And this is an example of the sort of the NWP field on which the charts are drawn. So I think this is showing dew point, for example, but there's various other parameters you could overlay to help gauge an idea of where fronts are most likely to be, and other features for that matter as well. An increasing important aspect of what we're trying to do is short period forecasting, particularly convection. That's one of the Met Office's more strategic aims, is to improve our nowcasting. And one of our biggest challenges is getting thunderstorms right. They aren't handled particularly well by models around the world. They're quite challenging to get right. If you have a weather app, you'll notice that on showery days, the detail tends to change hour by hour. So one thing we're really trying to focus on here is improving our short period forecasting for heavy showers, thunderstorms, which can bring obviously the risk of flooding in particular in the UK. That's probably our biggest, most common hazard in the UK, is heavy rainfall leading to flooding. So what about this National Severe Weather Warning Service? Very quick overview of what these are. I'd like to also just give thanks to my colleague Dan Surrey, who has provided some of the background to these slides rather than me having to make them myself. It's our public weather warning service, which is aimed at the general public, businesses, emergency response and government. So everybody who may be interested will be a recipient to this service. Established on the back of the 1987 Great Storm. Before then, there weren't any official warnings issued like this. Now it's evolved through the last 37 years or so into the impact-based warning system that it is today, covering a variety of hazards, which are listed down the right-hand side here. And it's been proven that issuing a warning, an NSWWS warning, is probably one of the most effective ways to communicate to a large group of people that the potential for impactful or dangerous weather in the future. It used to be a threshold-based service. Now it's an impact-based service, which means that it's a little bit subjective as to where certain warnings may fall on the matrix, which I'll show you in a moment, and you may be familiar with. But I think it gives a better warning overall. And I say we warn for these 8 different types of weather you can see on the right-hand side. A little bit of history then. So it goes back, basically launched in 1988. Big review happened in 2007. So some of you may remember that the summer of 2007 was particularly wet with some quite serious flooding, particularly across parts of England and Wales. Off the back of that, we developed the Flood Forecasting Centre, which brings our ties to the Environment Agency and Natural Resources Wales much closer. And so it's very much a collaborative way of working now when it comes to considering the impacts of heavy rainfall across parts of the UK. In 2011, so the warnings switched from a threshold-based service to an impacts-based service. So that's factoring in likelihood of something happening with its expected impact. For example, in the old days, we used to warn for, I think, 15 millimetres of rain in 3 hours was kind of a basic rainfall warning. But if you just had a dry spell, then that might actually be quite beneficial. So why would you warn for it? Now, depending on what the antecedent conditions have been, has it been very wet recently? 15 millimetres of rain may actually cause quite a lot of impact, or it may cause absolutely none. And it will vary depending on where you are in the country, in the time of year, etc., etc. And then in 2015, we started naming storms, initially in collaboration with Met Éireann, so the Irish National Met Service. And these work hand in hand with the national severe weather warnings that we issued before. In 2018, then, we moved from, I think, 5 days to 7-day lead times with warnings and added thunderstorms and lightning as well. In 2019, the Dutch National Met Service, KNMI, joined the name storming collaboration. And then in 2021, extreme heat was also added as a parameter for issuing warnings. Possible, I think, under consideration is whether we need to consider extreme cold as well, although in a warming climate, that may be less of a consideration. Here's an example of what a warning looks like. So I picked this one from Storm Isha back in January. So a very rare red warning issued across parts of northeast Scotland. And just to give an idea of what we've got in this, obviously got the map with the area affected, some kind of headline facts and potential impacts, some background information, where it sits onto the important warning matrix. So a red warning is a high likelihood of high impacts. And this is how the warnings matrix basically works. So we've got the further towards the top right, the more severe the weather. But sometimes you may have a very low chance of high impactful weather occurring, but not much confidence in it. So you may go in towards this bottom right-hand column, or you may be confident that there's reasonably high chance of something occurring, but won't be necessarily that serious. So you perhaps be more towards the top left. So where you make the decision on this matrix, it depends on a lot of the collaborative chats you have with some of our partner agencies, getting the feedback from CCAs, and ultimately to that risk versus likelihood basis. And it's really important to say that the location of the tick in this box is the most important element when you view a national severe weather warning, not necessarily the colour. You see there's various shades of yellow, for example, and that can range from anything between something that's potentially very, very high impact, but we're not very confident it'll happen, to something that's high likelihood of something happening, but it may not be actually that serious. So yeah, it's quite a complex process, can be quite time consuming, but I think on the basis of processes at the moment, we issue better warnings as a result. So that's the UK side in a nutshell. The other side of my job in the Expert Weather Hub is the global forecasting side. So there's 2 tiers to that. One is basically UK government interests for UK nationals abroad. So any overseas territories we have, it could be people on holiday, it could be people working, you name it basically. And one of the things we issue, basically our sort of flagship issue product that we issue for that, is what we call the Global Weather Impacts Assessment, or the GWIA as it's affectionately known. And this identifies basically anomalous weather or severe weather around the world. So some places in the world will be very wet at certain times of the year. We expect that. We expect impacts. People are used to that. But if you have particularly heavy rainfall, for example, across India at the moment, then even though it's a wet season there, it may still cause additional impacts over and above what we might expect. So that's kind of the way of thinking on this map here. And the notice of the matrix on here again, a little bit like with the national severe weather warnings, further towards the top right, the more severe the weather is, if you like. And it's basically around our perception of how well a given country can cope with the weather that's kind of beset on them. And if it's likely to have long-lasting serious impacts, then that's generally obviously towards the more severe and close towards that top right-hand corner. The other side of my job is to support some of our teams working around the world. So we have teams based at various defence sites on the Falkland Islands, Ascension, Cyprus, Gibraltar, and occasionally elsewhere as well. And again, this is an appraisal of various models that I can look at, coming up with the overarching narrative. And then the teams on the ground can add the detail. And obviously they understand the customer perhaps a little bit closer than perhaps I might. So that's the Expert Weather Hub in a nutshell. Marine, or specifically PWS Marine, so it's like taxpayer marine, if you like. Various products in this sector: inshore waters, shipping forecasts, the warnings that are tied in with that, high seas forecast, which goes out further into the Atlantic, and the warnings tied in with that. The various coastal reports, outlooks, and the general support to the Maritime and Coast Guard Agency, and the issue of hindcasts. For example, if someone was missing at sea, and they wanted backdated information on, say, winds and currents in case someone had drifted off somewhere, or within the basis of basically SOLAS, the safety of life at sea, most recent amendment. That was 1974, and we sit within that for basically safe navigation at sea. All the forecasts basically compile 5 different things, really. So the general synopsis. So if you ever listen to shipping forecast, you'll be aware of that. Information on the wind speed and direction in Beaufort force. Information on the sea state, which is based on significant wave height. The weather, and then information on the visibility and, if necessary, on icing. During the Beast from the East, I was doing the inshore waters that night on I think it was about the 1st of March 2018, and putting icing in Sea Area Lundy was quite an unusual and probably unlikely to be repeatable, he says, thing I'll be doing again. So that was quite a unique night. This is the inshore waters forecast then, out to 12 nautical miles around the UK coast, covering 19 regions around the UK coast as well, and issued 4 times a day. There's also a Shetland waters forecast, which is issued by our colleagues in Aberdeen, which goes out to 60 nautical miles out from Shetland, and we get contributions from Jersey Met on the Channel Islands and the Isle of Man Met Office for their local waters forecast, which we feed into the product, which ultimately goes out. And here's an example from one of the forecasts from yesterday, just give an idea of a typical forecast. So you've got the wind in you've got the first 24 hours, information on the wind, some information on the sea state, weather, and then visibility, and then an outlook for the next 24 hours. So improving conditions for this part of the coast, number 6 here, for this period. And the shipping forecast expands out a bit further into the Northeast Atlantic. 31 regions are all displayed on the right here. Again, issued 4 times a day. Trafalgar only issued on the midnight issue. Not quite sure why, never quite understood that, but it is. Follows very strict geographical order. So starting with Viking and the North Sea, going all the way around the UK coast, down to Trafalgar, back up the western side, and finishing in southeast Iceland. It's a very unique product, this. So you have to start in one end, one part of the area, and work your way around. So you can group areas together, but they have to be adjoining areas. You can't just pick Viking with Rockall, for example, without including all the ones in between. So it can make writing quite tricky if the weather doesn't sort of conform on a given day. You can split areas as well. So if you fancy giving the announcer at Radio 4 a headache, you can have sort of south-north at Sarah, north-south at Sarah, or south-west, south-east Iceland if you want to be a pain. Probably wouldn't be popular if you did it every day, but every now and again that is required. And this dates back over 150 years, and it's probably the flagship Met Office thing, forecast. And it ultimately is, kind of where the Met Office originated from. So back in when was it? I've got this written down somewhere. 1859, wasn't it? The Royal Charter was wrecked in a storm off Anglesey, and 450 people lost their lives. And Vice Admiral Robert Fitzroy, who founded the Met Office, basically started off producing these forecasts, from which the Met Office has grown from since. So it's from the shipping forecast that our current network of forecasting originated. And here's an example just from 40s, so in the middle of the North Sea, just from yesterday. Again, similar structure to the inshore waters, an example of some of the information you could see in there. For warnings then, Beaufort scales are used. So with inshore waters, we look at force 6 or stronger to be consideration of warning. For shipping forecasts, gale force 8 or stronger, and for the high seas, storm force 10 or stronger. And I guess this is largely correlated to the fact that near shore there'll be smaller vessels which are more prone to strong winds and the impacts they may bring. The high seas then, most of the North Atlantic, extending right up into Canada, into the Arctic as well. 13 areas. Some of these include the shipping forecast that are butt onto this. Each area can be split into 4 subzones when you're writing this, because you can imagine there's huge areas of open ocean here. So sometimes it helps to carve off a bit if you want to focus on one particular area. And occasionally we do get Atlantic hurricanes drifting northwards into the south of this area in particular. To that we refer to the National Hurricane Centre guidance for this. And here's an example from Denmark Strait from the other day. Again, just some of the weather you get in these parts of the world, and right in it you can end up with hurricane force winds, really high seas, superstructure icing, just the sort of weather. And some meteorologists such as myself, have worked offshore occasionally on this particular boat, actually. And we're very interested in things like swell, the components of the waves. So swell and wind waves, wind speeds are very critical, and you work on board. I think I work just there, and in the middle of the North Sea and somewhere off Trondheim, off the Norwegian coast. I was dismantling a part of an oil rig, but you can see it's used to assemble wind turbines and all sorts of other things. And some of the data is much more niche, much more sort of site specific, as opposed to the area forecast that you see in, for example, the shipping forecast. So yeah, that's just a little aside as to some of the other things that we do. I think that's it, and I'll hand you back to Amy.
Cheers, Steve. Right, I will attempt to share my screen better this time. Hopefully that's come up all okay. So I'll return back to aviation, which is one of the benches in which I work on. So for the Met Office, it's one of our largest squads that we have in the operations centre. We've got about 70 staff spread across 4 operational locations. So we do also have an operations centre up in Aberdeen. We have meteorologists working at Heathrow Airport and also at NATS as well. And for that, we do a combination of regulated and commercial aviation services. So that could be for the CAA, so things that have to be regulated and definitely done, and then also sort of commercial customers, and that's sort of Heathrow or other airlines that are looking for sort of a personalised forecast. So why do aviation need a slightly different forecast? So I've just put up here just sort of a brief cloud structure idea. So there are different types of clouds. So when you're flying through the air, there's going to be hazards associated with different sort of cloud types and synoptic setups. We've got a brief idea here of sort of what kind of flight hazards you could see. So you do have a combination of both in-flight hazards. So thunderstorms could cause an issue for landing with erratic winds, hail, a whole lot of different hazards in there. Icing, so if you can get icing forming on the aircraft as well, that happens in certain types of cloud. Turbulence, and also parts of volcanic ash. There's lots of different hazards for aviation in particular, that's different to sort of a public weather forecast. So with that, one of the main things we produce is something called a TAF. So some of you may have seen this before, but here's just an indication of just a couple at the top. So it's a coded weather forecast. I'll just quickly go through what exactly that entails. So what we normally have is each of the benches will look after TAFs. So these are going to be specific weather forecasts for individual airports. This, for example, is for Belfast today. So you have a 4-letter code, and that indicates the name of the airport. And then you have a code which is the date, and then the time in which it's issued in Zulu, indicating what time zone it's for. You have the code of the issue time. So this is 17:06. So this morning until tomorrow 0600. We have a wind forecast in there. So the direction, 360 degrees in knots. We have a visibility section here, and if it's all the 9s, then it's the maximum it can be, and then a cloud amounts and base. And then further down we have sort of prob 30s, so the likelihood of different things. And what we're looking for really is changes in the cloud base, so that can change when a plane comes into land, and the height at which it can see the ground, and therefore whether it's safe or not. Also, things like winds are very important, whether or not it's going to be a crosswind. And basically we have, it's very easy to understand, so it's clear across all languages. All pilots are trained to understand this specific forecast. And it just makes it really clear that the weather should be within certain parameters and how likely it is. So prob 30 is a 30% chance. Becoming is something that will change over a period of time. And it just makes it much more simple for aviation, that a very coded, very specific forecast. This is a very aviation-specific product that we produce. And below we just have a METAR, so every hour or every half an hour, you have an observer on the ground, making sure that the weather forecast is fitting in within the bounds of this TAF that we are producing as well. So what does that look like? It can be color-coded, so this is a satellite image from earlier on today, whereas blue conditions generally quite fine, and if you've got a lower cloud base, so more difficult for a plane to land, you can see it colored-coded up, something poorer, so green in this situation's a bit lower. So it just gives an idea for a pilot, a colour coding easy system to see where it is safe to land. Now, further up through the atmosphere, there's another bench that we have. This is called the low-level aviation charts. This is a bench that I work on, and this is everything below 10,000 feet, and it's for a portion of the UK and across parts of Europe as well. Now, the idea of this is for planes flying between the surface and 10,000 feet. So this is usually smaller aircrafts. Your commercial air flight airplanes are usually flying sort of above, sort of close to sort of 30 to 35,000 feet. And this is the main idea of this, is to, again, using those codes that a pilot, again, will understand, and with sort of thresholds that they'll understand where, if you've got a certain visibility, they'll know whether or not what the realms of possibility either side of that are. Basically, it's just about lumping together different weather characteristics. So you'll try and create, as we've only got a very limited area, so it's just this size box to describe all the weather, the main hazards, and sort of lump it together. And what this basically does is allows sort of the most hazardous air weather features. So if you've got thunderstorms, you can see exactly where those are. So if you're a small aircraft, particularly sensitive to anything, you can see where the main hazards are and where they're likely to be, and you can make sure you can plan your flying to exclude any potential risks to your flying as well. We are also in the aviation. We have part of one of the WAFCs, so it's World Aviation Forecast Centre, and it's basically the whole world split into two, and it's between us and Washington in the United States, and this is everything above 10,000 foot right up into basically everything above 10,000 feet. So this is something that sort of commercial airliners will use, and it just indicates where you can see turbulence and sort of the main like thunderstorms, which could be hazardous for flying as well. Another bench that we have here is media. So again, I work on this bench, so I've just got some little hints of what we do. So we use a visualization software called Visual Cortex, and we use that to create videos, and we use that for our customers. That's ITV, Channel 4, Channel 5, and GB News as well. We'll use some of our presented input as well. So we help produce some of those graphics, adapt them if there's some errors from the models, as Stephen mentioned before, like if there's something that's not being represented very well. As an advisor, we can manually add those back in to make sure that the graphics that sort of the public is seeing most match what's expected in the forecast. We do a mixture of updating some of these graphics. We also brief presenters, so again across those across sort of ITV, and we also write scripts for those places, particularly if for those to use, particularly if there are presenters who are not present on certain days. So sometimes it's used as backup, and sometimes it's used as just the straight scripts that are getting used on those. We also produce the PWS scripts that go on the bottom of the website. So if you click on your area and then you scroll a little bit further down, you can see a little synopsis of your area. We're one of the benches that also produces those, just gives a little bit more of an overview rather than just the very specific area that you can see on the app. We also, as part of here, manage social media content. So just got a little indication of that. Sometimes putting satellite images up and making a plan for the day of what would be most interesting to relay. And also on the weekends, some of us, including Greg, do produce presented content on the weekend as well. As part of the media team, we're also responsible for answering any out of hours press requests, and also sort of through the afternoon. So if newspapers call up and want to know about a certain story and they want to speak to a forecaster, then it's the media team that they speak to. Moving on, so we have, again, another broad area, which is surface infrastructure. And I've just got a highlight of some of the things that we cover in this bench. So again, a wide range of customers, so energy, industry, and it's looking at any hazards that could affect, for example, if you have very strong winds, how could that affect the power lines? We had forecasters at Wimbledon, we have across sporting events as well. So this is one of those benches that has quite a lot of variety, lots of different customers with lots of different requirements. And we also have the Talk to the Forecaster service here. So this is usually when people anyone who wants to speak to a forecaster specifically can make a one-off payment and they can speak to a forecaster. So this is just one of those areas. It has just quite a lot of variety within it as well. We also look at sort of the road network. So sort of we have contracts with national highways. We look at gritting, particularly in the wintertime, and particularly any areas that come up. Steve did mention about the Flood Forecasting Centre. So just a brief slide to mention here that, again, it was founded in 2007, the back of the Pitt Review, and it's now a combination of both forecasters and hydrometeorologists. So these specific forecaster or operational meteorologists are trained in both hydrology and meteorology, and they look at both what the ground is doing and what the rivers are doing in combination with what's falling from the sky to make sure that we've got this very rounded idea of what the flood risk is going to be. And for this, it does include all sorts, so river, surface water, coastal, tidal, groundwater. It looks at storm surges. So this combined effort for people, combining weather and what's already fallen onto the ground, it just gives us a much more efficient and effective way of providing flood guidance to the general public. This is just a picture from many years ago, as at the moment it's generally not too bad. So moving on to another large and broad bench that we have at the Met Office called hazards, and it can really involve anything that could be potentially hazardous. And it really is one of those benches where it is quite variable depending on what's going on at the time. So we do have quite seasonal things. We have the UV and the pollen comes under the hazards bench. And one of the main things is the volcanic ash. It's a volcanic ash zone that we look after. So we look after London, which includes Iceland. And as I'm sure you're aware, it is very possible to see some volcanic ash plumes coming from here. And the idea for the hazard bench is to have a look at these plumes, look at the type of plumes, look at the wind, and combine those things together and produce forecasts to indicate whether or not there's going to be a risk to aviation and exactly where that's going to be as well. We can include anything, air quality, wildfires, basically anything that could happen. That is something that the EMARC bench will cover as well. Moving on, we'll go to the space weather bench. So again, space weather, I'm sure everyone's probably aware of it after the recent aurora that we had not too long ago. But the primary function of our space weather bench, so we do have a specialist that looks at the output from the sun and to see how that interacts with the Earth's magnetic field. So it's looking at radiation and matter that's ejected from the sun and seeing how that interacts with the Earth. Space weather has been recognised as a potential threat to the UK by the government, and it's on their national risk register. So whilst we do often advise about whether or not the aurora could be visible from the UK, the main thing is whether or not there's going to be any risk to infrastructure. So it could have all sorts of impacts, such as sort of GPS, radio communications, and potentially at risk to the power grids. But when they're warned ahead of time, then it's something that we can mitigate against. So this is sort of the primary reason why we have a space weather forecast at the Met Office. And just quickly before the end, I thought I'd just go through a quick bit on the process. So that's all the different ways and the different benches and the different types of forecasts that we get or that we produce. But how do we produce a forecast and what do we really mean by that? So this is an extremely brief overview. But the idea is to work big and then come back smaller. So we've got a synoptic chart on here, as Steve's mentioned, is drawn by the chief forecasters. So we'll look at the synoptic chart. We understand all the theory around sort of high pressures, low pressures, frontal systems. You get an idea of what you're expecting for the weather in your location based on the theory that is represented with these charts. You then have a look at the upper level. You have a look where the jet stream is and the strength of it. And you look at that large big picture first. Then we do a comparison to reality, and there is many ways that you can do that these days. So this bottom left-hand image is what we call an RGB. It's where we use satellites to put false colors depending on different wavelength attributions to the sort of pictures we produce. So what the ice crystal content is, what the temperature is, and from those we can create lots of different false colored imagery. So for example, this one on the left is just showing cloud top height. So it's just one parameter that we can use to see whether or not the model is doing a good job and how far we can trust that going forward. Similarly, there's other, we can see on here, there's lots of different models we can use, lots of different wavelengths we can look at. So this is an indication of what the model thinks the satellite image should look like, and then you can use this sort of sliding mechanism to see whether or not it matches. So it really is key to relay anything that you see back to reality to check that the model's doing a good job. Always verify as a forecaster. And again, having a look at the satellite images, seeing what it's doing close to the ground. And then we have to go in and add the details. So this is a tephrogram, which some of you may know about, probably a bit too detailed to go into now. But effectively, you're looking at a slice up through the atmosphere. So not just at the surface, we're going to look at that cloud content and the winds right the way through the atmosphere. And depending on which bench you're looking and you're working on, will be which hazards that you'll be looking for and which can be helped to identify with this tephrogram. We have, especially with the new supercomputer, so many models to look at and so many parameters. Again, it's down to the forecaster on the day exactly what they're looking for. But you have temperatures, heights, loads of different parameters at all different levels, and you look at a slice of those and you really hone it in depending on which of those benches you're working on and which hazard is going to be most applicable to you on that given day. And that's the very brief synopsis. And I think I'll hand back to Greg and see if there's any other questions.
Lovely, thanks, Amy. Yes, we've got lots of questions coming in. I tried to quickly give some replies to some of them to give a quick overview. So if we just run through them and see how many we can answer, we might go slightly over time, but it's a good opportunity to have 3 forecasters around to answer some questions. So first one, I'll go through the ones that are open at the moment, and then I'll go back to the ones that are I put a brief answer to, because at least it links to a semi-answer. So we've got Paul that says, do you have any plans to increase the amount of raw NWP information available via open data, similar to what has been done by ECMWF? I don't know if you have anything to add on that one, Stephen. I know it's something we're working on and pushing more out. For example, windy.com, all our high-res data is now, as of, I think, was it the end of last year, sort of available from there as an output, which is good.
Yeah, and I think that's probably the direction of travel. I'll be honest, I'm not 100% sure of the plans, but I think there's certainly an awareness that some of our data kind of almost appears to be a bit held back, which doesn't sit particularly comfortably with me, for example. I feel, there's no harm in sharing it, is there? So I think it's probably watch this space. It is an awareness the Met Office have that not all the data is readily available to everybody freely, as say from EC or other model centres for that matter. So I think it's the direction of travel. I would expect more to become available over time. I don't have time scales on it, but I would expect that to be the case.
Brilliant, thank you. And do you give weather forecasts for railways, and can the general public access them to look at? I know I've definitely done it in the past. During open road seasons, we'd also look after the some of the railway lines. We would give leaf fall forecasts. I know that was sort of done in recent years as well, particularly during the autumn, as leaves coming off the trees can affect the lines and therefore sort of speed of travel. But I think quite a lot, with so much data available now, I think quite a lot is automated and put out there as data to customers. So it probably gets fed directly to them. So I don't think there's anywhere sort of online that sort of gives that detail, but it's, if we sort of do have some customers in the background, it's sort of more of an automated process, as we have with many customers these days. Sort of getting the data feed to them is a simple and easy sort of achievement now compared to, say, 10 years ago when we were doing it more manually. Don't know if you have anything else to add on that.
I don't think so. I mean, as you say, yeah, the background data feeds are a complex beast, aren't they? And lots of people get lots of raw data feeds. I don't think Network Rail or other train operators get a forecaster intervened or advisory service at the moment. But this is
they can phone up for a talk to a forecaster, as Amy was saying, to get more information.
And of course, while the Met Office is a unique organisation, as much as it's a trading fund, so part of our funding comes from the government, but we also put out for commercial contracts as well. And for example, someone like Network Rail would be a potential customer, and it has been in the past, maybe again one day, and that would be something that could be discussed depending on what the customer wanted.
Yeah, brilliant. Thank you, Stephen. It's a good question. Do we have any up-to-date satellite imagery routinely available on the website and app? It used to be on the website in particular, but isn't at the moment. I suppose a quick answer to that is, yep, great feedback and something we can pass on, Ken, and then we, feel free to fill in sort of the inquiries page on our website, as well as sort of we're constantly updating and changing the app and website, and it is one of the features on there. There's model cloud cover, so you can see the cloud cover sort of going forward, but there isn't currently sort of live satellite imagery on there. It could be like a data issue with sort of having that on there, maybe. I'm not fully sure, but yeah, good point and question, and definitely can be fed back. Do you have any formal mechanisms for assessing the accuracy and utility of your accuracy of your forecasts? That's probably a good one for you, Stephen, being in the Expert Weather Hub.
Yes, there are, without sort of wanting to shirk responsibility. The actual verification is it's not necessarily part of my remit. Obviously, you're doing it in your head all the time, and any meteorologist worthy of their place will be doing verification of their forecasts and the wider situation all the time in order to produce the best possible forecast on the day. Our forecasts there's an automatic verification, which I think basically takes our various parameters within our global model and other models and is automatically verified against satellite data, which can basically feed back quite a lot of information as to the accuracy of the model without anyone really looking at it. That's a very simplified way of putting it, but it comes back as the Met Office models are some of the most accurate in the world. It may not always feel like it when the forecast doesn't quite go to plan, but compared to a lot of models, it consistently comes out as one of the best, if not the best. There are other ways of verification as well. So, for example, national severe weather warnings are verified by humans. They're subjectively verified, so it's a little bit dark grey areas as to whether a warning, when it's issued, was it the right warning? Did it have the right impacts? And these are based on feedback from the ground, feedback from our civil contingency advisors, and it can be a little bit sort of to and fro as to whether we agree on the final outcome of that, but that's one area of verification that occurs with a lot of human intervention because of the nature of the product. It's issued by a human based on lots of things that are a little bit subjective in the first instance. So that's something that I'm kind of partly involved in sorting out with my non-operational time.
Lovely, thanks. Go on, Amy.
There's also I was going to mention, like in aviation, I talked about the TAFs that we have. So that's another thing that we do verify, and whether or not those forecasts were, we have all the observations and it's very regimented. So you can very much check those. That's another thing that we do check, and we do have like targets and KPIs in the aviation world to make sure that we're fitting into those as well. So that's another way that we do check that we're being as accurate as we can.
Lovely, thank you, Amy. I'll quickly go to some that I've sort of partially answered. Roger asks, where does AI fit in? Which is a huge question. Part of the events committee, I created a meteorology and AI event. So if you're an RMETS member, you'll be able to go back and watch that. That was in March earlier this year. We had Google in there, ECMWF, talking about their machine learning forecasts. So I've quickly sent you a link to sort of the Met Office sort of stance on it, and obviously it's a growing area and fast moving area, and we have set up since last year sort of an AI team for basically looking at our numerical weather prediction and using AI to sort of combine the two and improve the forecast. So it is an area that's sort of up and coming and ongoing. So it's a nice read to give an overview on that. But yes, AI will definitely 100% sort of form part of our forecasting world, even down to perhaps like script writing. At the moment, they're all done by humans. Everyone knows ChatGPT, etc. And at some point, that'd be something we could look into, and perhaps even helping with warnings to narrow down warning areas better. And so there's lots that can go into it. So it's definitely one to watch. But it nicely links into sort of the next question as well, which is about sort of what are the next steps with our sort of model data and upgrades. So hand over to you, Stephen, if you want to talk a little bit about the next steps, short term and longer term, if you want.
Well, I'll try. So essentially we've got some very exciting news. You're probably aware that we're about to go live with our next generation supercomputer, which will make the one we've got at the moment seem very, very small and simple in comparison. So this computer promises to give us huge computational capacity, which there's numbers in there that I wasn't even sure they were even numbers, to be honest. The amount of calculations this thing will be capable of doing is truly phenomenal. What does it mean for weather forecasting? Well, theoretically, it means we can run more models quicker, higher resolution models quicker, more ensemble forecasts. So we've talked a lot about our global model. That is a deterministic model that gives you a value at a time frame, just a yes or no answer, basically. An ensemble is, how to put it in very simple terms, multiple runs of the same model with slight tweaks at the start, which lead to countless different outcomes down the line. And the further you go into time, you get like a more of a spread, but you can detect trends, you can detect most likely scenarios. With a more powerful supercomputer, and also with the running of AI as well, you can get ensembles that have far more individual members, so much more information, running quicker. So lots of positives in there. I suppose a negative from a practical point of view is that there'll be more data to look at, and how do you rationalize that data, and how do you not get swamped by it, so you're not presented with too much to look at as a meteorologist. So that's something that we're looking at now, and we're trying to work on the best way to look at these diagnostics in the future. But yeah, basically, so it's going to be a fire alarm test. This is classic operations center, so I'll compete against it. Hope you can hear me still. But yeah, basically, I think high resolutions, more runs, and ensembles will be coming our way in the next few years. And I'm going to stop while the fire alarm goes.
Yeah, thank you, Stephen. I'll leave the next question, which may be sort of slightly more for you in terms of the matrix. Gosh, lots of questions still coming in. Let's see if I can. I suppose some of them are slightly sort of similar. How is AI changing forecasting for your jobs? Well, a good example there was, as we just said, sort of script writing. Sort of, it would take away a lot of sort of background jobs that we still do, that we don't necessarily need to be doing, and it will give us more time to look at sort of the model trends that are there and explaining to customers. Sort of Amy and I, as sort of part of the media team and media forecasters, are sort of really looking at the overall story, sort of turning temperatures are rising in the southeast the next few days. It's sort of how high will they get, how long will it last, why is this happening, those sort of questions. Looking at the data for a non-Met person, it's very difficult to sort of get those answers quickly. So I think sort of one-on-one or sort of person-to-person sort of forecasting and sort of coming up with the story and then explaining that will always be there. And that's, to me, why I'm in the media team, because I think it's the most fun sort of part and the most enjoyable part for me. But yeah, I think some things will change, and they'll continue to change as they have done over the 15 years I've been doing the job. But yeah, I think that probably covers that bit. How come short forecasts in the local vicinities are still not accurate, no matter how much tech is thrown at it? Why is it showering here and was not in the forecast? That's a... Oh, I don't know if my screen just went away. Can you still hear me okay? See me okay?
I can still hear you.
Okay.
You are a bit blurry though.
I am blurry. I don't know if you want to answer that one, Amy.
Yes. So, I mean, in the short term, I mean, we use the kind of analogy for showers, like boiling water in a pan. You can be sure if you're boiling water in a pan that you're going to, produce bubbles. We can say within a certain area we're pretty confident that showers are going to be produced. But there are so many little factors that come into it. And actually, we can reduce the grid sizes of these models, but until you could resolve every last geographical feature, there's always going to be something. And especially in sort of a showery situation, there's always going to be some elements that are almost random in nature that you are always going to struggle to reproduce. So it's, again, like what we try and do is accurately display areas in which we are confident that something will happen. Like, for example, like this area, we are confident that showers will happen. And it's about the messaging, I think, that we're trying to improve. And I think expecting a model to be able to, even with the supercomputing capabilities, to be able to pinpoint every last individual shower cell across the world, or even in the UK, is probably going to be an unrealistic aim. It's when they get those sort of larger features that we're a little bit better on them. But yeah, it's trying to be about the communication. So, until you have a model resolution that's like a millimeter, there's always going to be some small dynamics that could influence where you start to see shower formation. That's probably why on showery days it does feel a little bit like you're seeing some inconsistencies. But I mean, reality, the showers are quite small, and you could see showers in one town, and a couple of miles down the road it will be dry, and it is going to be very difficult to really precisely do every last shower, no matter how good the model gets. But I'm sure in our lifetime that may happen, but I think it's a long way off being realistically possible.
Yeah, indeed. Thanks, Amy. The shipping forecast areas you forecast for have historical origin. Do you now have international responsibility for these, or does Ireland, for example, issue their own shipping forecast for the seas around Ireland? Quite an interesting question.
Yeah, that is a good question. So I know that Met Éireann will issue coastal forecasts, kind of similar to our inshore waters forecasts around the Irish coast, and you can find them on the Met Éireann website. It'd be fairly obvious where they are under the marine section. I'm not sure actually if they issue the same forecasts for the overlapping areas, or whether we have jurisdiction over that essentially. But I know, for example, the Norwegian Met Service issues equivalent to shipping forecasts for areas along the Norwegian coast, and again the inshore waters. I know I've looked at some of that when I've been offshore off the Norwegian coast, just to make sure we're going for the same thing. And for example, the National Weather Service in the US issues high seas forecasts for areas further south in the sort of tropical and subtropical Atlantic. So yeah, we have kind of our remit across kind of the parts of the North Atlantic, where we kind of are the authoritative voice, if you like, whereas other countries issue marine forecasts as well. So the particularly near the coastal areas, it's probably more likely to be the local Met Service that issues the forecast for that.
Okay, thanks, Stephen. Do we use Doppler radar? If so, will it be something that's available to the public at some point?
This is a good question, something that I know we in my team argue about, and a lot of countries do make Doppler radar information publicly available, the USA being a prime example of that. I don't know whether it's going to be made publicly available anytime soon. I would personally hope it should be. Yes, we do use it, and we can see access. We do have access to it here. So if you remember when I was talking about some of the sort of nowcasting forecasts that we do, quite a lot of the information used to generate those very short-term forecasts is based on radar imagery such as Doppler radar, where we can get an idea of storm relative winds and what may be happening very locally, as opposed to whether it's just raining or not. So that's one of the advances we've in the last sort of, I'd say, sort of 2 or 3 years, we've really started using on a regular basis for some of our internal products, which go out to those who kind of really need to know. So emergency responders, those who are very, very interested in sort of flash flooding, which is the big hazard resulting from this most commonly in the UK. So yeah, yes, it is there, but it's not easily available, and I don't think our radar our Doppler radar is publicly viewable at the moment. But I think it should be personally, and like with some of the NWP data that's not necessarily readily available, you would hope that perhaps in time it will be.
Lovely, thank you. Are we involved in agromet forecasts? This might be quite a good one for you, Amy. E.g., lamb wind chill, or shelter belts. Yeah, do we do anything like that?
So I'm not quite sure what you mean by agromet, but we do have something like that we produce in the Falklands. So we've got the sheep chill factor that we produce. So that is something. And I suppose with anything with the sort of surface infrastructure, if a customer comes to us and looking for a certain parameter, then we can produce it. For example, in the Falkland where sheep safety is very important, we do produce a sheep chill factor forecast. So yes, we do, for example, in the Falklands.
Yeah, brilliant, Amy. I think that sort of covers that sort of bit. So yeah, it sort of comes under the surface infrastructure sort of area, and it's sort of a talk to a forecaster sort of service. So people want that type of forecast. So it's sort of like agricultural forecast, I think, sort of what it's alluding to, and sort of any sort of bespoke forecast like that can be set up. I've heard several. This one might be for another time, perhaps. I've heard several times about the Aberdeen office. Could you tell me a bit more about their responsibilities and how they relate to the Exeter office? Have either of you worked in the Aberdeen office at all?
So I have actually worked a couple of shifts on my way up to work at Lossiemouth. It's actually very similar to the Ops Centre in Exeter. They've got a number of aviation benches that cover parts of Scotland that are up there. And I think they have different liaisons with SEPA, and there's different mountain weather forecasts that they do from up there. But I mean, the Met Office did used to have benches and offices across the country as well. So this is just one of the ones where it's remained, and they still have use for it. But again, with lots of things being remote, some of that work can happen elsewhere, but it will be covering aviation benches and just sort of more Scottish focus of similar benches that we have across in the Ops Centre, but just on a slightly smaller scale.
Yeah, so it might involve sort of like some offshore work and sort of helicopters traveling, etc. They'll have sort of better knowledge of the area, say, than we do down here. But as with cross office sort of work, they sort of help sort of be our resilience. So marine forecasting, for example, can be done from Aberdeen. We've got marine forecasters up there. So if a sickness or something like that happens at short notice, there may be sort of forecasters up there who are capable of producing the marine forecast and shipping forecast and can do it up there, and vice versa as well. So we can take their mounting forecasts and PWS scripts into the media team, and so it's sort of a two-way street in terms of being able to do some of their work, and we can do some of theirs as well. I think there's one more question, but we may have answered it on the way. Do you use one global model for all your global analysis? Oh, we haven't answered this. And forecasts, or do you have high resolution over the UK, overseas territories, and sea areas you're responsible for? So basically, overall, what sort of our model structure? Do we look at other global models, I suppose, or other higher res models? Is the main question, I think, from that.
Yes, is the answer to that. So we have, here's a very quick crash course in global NWP. Let's see what I can remember here. So we have our global model, which oddly enough covers the whole of the planet, and it's at its highest resolution and mid-latitude, such as the UK, which is kind of handy for us. But then we have various regional models that we can use as well. So for example, in the UK, we have what we call our UKV, which is approximately 1.5 by 1.5 kilometer resolution, which obviously produces a high resolution model output in the UK and the immediate vicinity as well. There are other regional models around the world. So for example, we have one covering parts of the Middle East, where again there's obviously quite a bit of interest. For example, British military interest, for example. I think there's one in the Falklands as well. Maybe you might just be able to catch me on that. I think so. And then also we have things like our ensembles are basically global as well. How we visualize it is not necessarily quite as simple as that, but I think that basically you could use some of our ensemble data globally as well. And yes, we look at other people's models as well. We look at the European model from ECMWF. We look at the American model through GFS. The Canadians have a very good model. The Korean Met Service has a very good model. And then the ECMWF also provides its kind of, we call it sort of boundary conditions, the sort of start of a 10, if you like, to a whole range of high resolution sub-European models. So for example, there's one called Harmony, which covers, roughly Iceland to Central Europe, northwest to southeast. The French Met Service has one called Arpège, which is a global model, but they have a high resolution model called a Rome. So there's again loads and loads of model data, loads and loads of model data centers to look at, and we can look at them all, and it helps us make our decisions to boost our own model capabilities.
Lovely, thank you. And one final question. I know we've gone well over time, but thanks for all those listening and watching. I think it links back to sort of the warnings system. I gave a link to sort of our matrix system, but I didn't know if you wanted to pick that one up, Stephen, and talk a bit more about how sort of the yellow, amber, sort of red sort of matches the matrix system on our website. I think
yes. Yeah, it's a good question, actually, and it's kind of a question that keeps coming up from time to time, actually. So you're not alone in asking that, Len. So on one aspect of it, when you receive a warning and it's yellow, amber, or red, yeah, it's in some ways that is a little bit simplified because, obviously red is more serious than amber, which is probably more serious than yellow. But as you rightly say, that there are variations, particularly within the yellow sector of warnings. So I suppose the headline response to one of that is that when you receive a warning, check where it is on the matrix, because that is the key thing about kind of either the type of weather you may receive, i.e. how severe it may be, or how confident we are in such an event occurring. And hopefully that will be supplemented on any given warning by the further details, because, so for example, a thunderstorm warning almost certainly will probably go into the very low of medium category as a start of a 10 when we're producing a warning, because as Amy hinted at when it came to forecasting showers, we can be quite confident that an area of the UK will be at risk of seeing heavy showers, thunderstorms, and therefore potentially, the key word there is potentially, seeing the impacts from said showers or thunderstorms. But to say whether they will occur at one particular location is almost impossible. I would say, and that's even in the world of high resolution modelling. So that would be a very low of median, which is 3 along the bottom, 1 up from the 3 along, 1 up from the bottom. Whereas if we can be confident, what's another example? Yeah, so frontal rain, for example, much easier to forecast the areal likelihood of it happening, and because it puts us more confidence in the forecast, we can be more confident on the potential impact. So we can perhaps have high confidence of just low impacts from that. So that will be, just looking at the matrix on the screen here, that will be 4 rows up, 2 in from the right. So again, both yellow warnings, very, very different ways of, very, very different levels of A, impact, and B, certainty. So when you receive a warning, look at where it is on that matrix, because that's probably the most important bit of information you can get from that. And all the what to do statements, the further details will all marry to where it is on that matrix.
Lovely. Amazing. Thank you very much, Stephen and Amy. I think that comes to the end of this taster session. I hope everyone has found it really interesting and fun. It's been really nice listening to both of you, and thank you very much for joining.